So, what happens when an AI can just rewrite its own code? How in the world do you stop it from going completely off the rails? Today, we're diving deep into something called CAST. It's a new mathematical framework that's basically a digital failsafe for the most powerful AI systems out there, aiming to make them provably secure. And look, this is not science fiction anymore. We are talking about AI agents that could be executing million-dollar trades or controlling power grids, maybe even discovering new medicines. The upside is absolutely staggering, but a single mistake, it could be catastrophic. That's the knife's edge we're on. All right, so here's our game plan for breaking down CAST. First, we'll tackle the new challenge these AIs pose. Then, we'll get into how it draws a digital safe zone. After that, we'll see the safety gate in action, how it keeps an eye on itself, and finally, what this all really means for building AI we can actually trust. Okay, let's get into it. Here's the huge shift that's happening right now. We're going way beyond AI that just spits out text. We are now dealing with AI agents that can actually do things. They can use a Python interpreter to analyze live financial data, execute commands on a server, or plug into any API you can think of. This is a massive, massive leap in capability, and it brings massive new risks. Now, this is the really crucial point. We can't just cross our fingers and hope the AI plays nice. No way. The engineers behind CAST started with a very clear-eyed, sober assumption. The AI might actually try to find loopholes. It might actively try to hide what it's doing to get around our safety checks. So any safety system worth its salt has to work even when the AI is trying to beat it. So how do you build that leash for an AI this powerful? Well, instead of trying to guess every single bad thing that could happen, which is impossible, CAST takes a totally different path, one that's rooted in pure mathematics. It's all about creating rules so solid, they're less like guidelines and more like the laws of physics. And hey, if you're finding this deep dive valuable, do me a favor and hit that subscribe button. We do explainers like this all the time. Instead of checking every single specific action the AI might want to take, which again would be an infinite list, CAST defines an entire safe set. Just think of it like a very strict, fenced-in backyard for the AI to play in. Anything that happens inside that fence is provably mathematically okay. Anything outside, not allowed, period.
And this visual just explains it perfectly. You see that green area? That's our predefined safe set. Now, if the AI proposes an action, that's the red cross right there, that falls outside of this zone, the system just says nope. It blocks it. The action never even gets a chance to happen in the real world.
And this really gets to the heart of the paradigm shift. Traditional AI safety tries to predict if an action will be bad. CAST doesn't predict anything. It uses a mathematical tool called convex analysis, which basically ensures the safe zone has no weird holes or tricky curves to certify that the entire range of possibilities is guaranteed to be safe. It's the difference between a weather forecasting it might rain and a mathematical proof that 2 plus 2 will always equal 4. Okay, so this idea of a mathematical boundary is great, but how does it actually work in practice second by second? Well, CAST acts like a real-time gatekeeper standing between what the AI wants to do and what actually happens in the real world. It's this really simple but incredibly powerful loop. First, the AI proposes what it wants to do, and not just one single action, but a whole set of possibilities. Second, the CAST gate does a super fast mathematical check to see if that entire set of possibilities is inside the safe zone. And third, only if it gets a green light, only then is the action released.
And get this. If an action is rejected, the whole system doesn't just crash. It has two really clever backup plans. The first is what's called a dummy output, just a simple pre-programmed safe response. Think, sorry, I can't do that safely, or in finance, just a no-trade command. The second option, projection to safety, is just fascinating. The system mathematically nudges the unsafe action to the closest possible safe alternative, and does that instead. It actually repairs the AI's mistake on the fly. Now, this all sounds great in a sterile lab, but what about the messy real world? We're talking about AIs that are constantly learning, constantly adapting, where the thing they did a second ago feeds into what they decide to do next. How does the safety system possibly keep up with that?
This is where the monitoring becomes absolutely critical. CAST uses this powerful statistical tool called an E-process, and it's specifically designed to spot weird behavior, even in chaotic, unpredictable data streams. Look at this graph. As long as the AI is behaving itself, the monitor, that calm green line, just hums along. But the instant its behavior starts to drift towards an unsafe area, boom, the red and orange lines spike, sounding an immediate alarm. It's a constant, unblinking eye.
The key phrase here is anytime valid. What that means is the safety guarantee holds true continuously at every single moment. It is not a random spot check. So an AI can't just be good for 99 actions and then try to slip one catastrophic mistake past the goalie. The goalie is always watching, always ready.
All right, so let's zoom out and look at the big picture here. Is this the silver bullet for AI safety? Is this the thing that's going to solve everything? Well, to answer that, we have to understand a really fundamental trade-off that exists at the heart of trying to verify any complex system. It's called the verification trilemma. And basically it says you are forced to choose. You cannot have a system that is, one, perfectly expressive, so it understands complex, fuzzy human rules like don't be creepy. Two, is mathematically complete, so it's correct for every single possible safe action. And three, is efficient enough to check quickly and automatically. You can pick two of those, but you simply cannot have all three. So, faced with this impossible choice, what does CAS do? It makes a very specific, and I think very smart choice. It prioritizes sound and efficient verification. It doesn't try to read our minds or guess our fuzzy intentions. Instead, it focuses on rigorously, mathematically guaranteeing the enforcement of clear, black and white safety laws that we, humans, write down and give to it. And this quote from one of the researchers really captures the ultimate promise here. What this is all about is fundamentally changing the nature of AI risk. It takes that terrifying, unbounded tail risk, that 1 in a million catastrophic event, and it transforms it into a predictable, measurable, and auditable risk that we can actually get our heads around and manage. Now look, CAST doesn't claim to solve the entire thorny problem of AI alignment, but it offers something absolutely crucial: a rigorous mathematical foundation for containment, a practical engineering blueprint. And it leaves us with a really powerful question. Is this how we start building a future where we deploy powerful AI, not just with our fingers crossed, but with actual mathematical proof of its safety? Thanks for watching, and if you got something out of this, please don't forget to subscribe.